Hello, this is Michael,
And this is Ryan.
and this is Lab 10, Semiconductor Light Sources. Okay, so in part A of the lab, which was physical properties and spectra, we first made a measurement of LED dimensions of emission area using a microscope. To begin, we scaled microscope pixels to millimeters using a ruler and just convolutions. And we found that our LED dimensions was 1.87 by 1.87 millimeters. And we found a measurement of the laser diode cavity length as well, which the cavity length was 1.92 millimeters. Using that found laser diode cavity length, we were able to calculate the longitudinal node spacing, which was a peak value lambda squared over 2L, which L is the cavity length. And we found a mode spacing of 0.104 nanometers. Doing some research, we were able to come up that all our values are comparable to known values of these optical devices.
So for part B is our divergence bench, and we're measuring the power on our detector versus the angle of our source. We used both an LED source and laser diode source. And what we found was our laser diode has a narrower divergence. And from our graphs, we can see our LED has like a power output at about plus or minus 40 degrees. And for our laser diode, it's about plus or minus 10 degrees. And we also calculated the polarization ratio of our laser diode, taking our max to min um, output through our polarizer. And what we found is a ratio of about 105. So we also found the polarization ratio of our LED, and our output did not change when rotating the polarizer. And so we have a ratio of 1 to 1.
Okay, so for part C, we did power output versus drive current for both the LED and laser diode. We then graphed our data that we found. And for the LED, we found a pretty linear relationship with some decay to it, possibly due to the temperature effects. For the laser diode, we found a pretty constant relationship until the threshold current of around 21 milliamps. And above the threshold current, we found a linear relationship between output and drive current.
So after we used an optical spectrum analyzer to observe the spectrum of the laser diode as we change the current, and below the threshold current we see pretty even peaks with no dominant peaks. At the threshold we get a dominant peak, and as we increase the current above the threshold we see a switching of dominant modes due to temperature effects.